us today. This is our second webinar for our Carolina Canopy webinar series. Today's topic is urban tree design in the face of climate change, and our speaker today is Dr. Julietta Shirk. She is a professional landscape architect and associate professor in the Department of Horticultural Science at NC State University. She is also an associate faculty in the Department of Landscape Architecture and has her own practice, which is JTSLA. She teaches 7 different diverse studios and lecture classes there at NC State. She works with her graduate students by infusing an evidence-based approach and uses environmental design research strategies to address a variety of landscape studies with local and global impacts, which are published in peer-reviewed journals. She has coordinated participatory design, executing a variety of more than 30 service learning projects with her students across communities in North Carolina. And internationally. She promotes community and academic dialogue by advancing design excellence that contributes to the public sphere and improves the human natural experience. And today she's going to talk about things that you can do with when you can design the urban landscape with trees in mind. And with that, Dr. Shirk, I will hand it over to you.
Great. Can everybody hear me? There's
a little bit of reverberation on your end. I don't know if it's the microphone specifically.
Can you hear better?
A little bit better. We'll get started. People can let me know in the chat dialog box if you can hear her on your end as well, if you're getting any kind of reverberation. It might just be on my side, but
yeah, I noticed people still have their speakers on, which may be impacting, but anyway, I'm not sure what that is. Are you hearing what I'm hearing instead of a background?
Yes, that's what I was talking about. I don't know if it's your headphones.
No, I don't have headphones up.
Okay.
Yeah.
I'm trying to look at it now to see what might be going on.
Is this any better?
It can still get a little bit of reverberation, but we can get started. I'll see. I'll be working on my end and then see if I can figure it out.
Okay, so hello everybody, and thank you for the introduction, Leslie. I wanted to ask who is in the audience. If you could put in your chat box who you have questions are. Leslie, if you could take a picture.
All right. I'm going to keep an eye on things as they come in. Everybody just wants to send a chat message to everybody, letting them know what your background is, what your position is with your organization. It just gives Dr. Shirk kind of an idea of what's going on and who she's presenting to.
I suspect we're all in the same industry and are already advocates for trees. So I see city arborists, good. Horticulture, arborist, good. I see some coming in the chat. Government administrator, awesome, terrific. Urban foresters, planning foresters, awesome. We're all on the same team, great. Invasive program coordinator, wonderful. A ranger in the Forest Service, wow. Retired forestry professor, awesome. Great, so a nice range of different folks with different backgrounds. I'm a designer primarily and a teacher and a professor. So I'm going to bring some of my perspectives to the table. And I know I'm speaking to the choir more or less, but I wanted to just establish that, you know, we're already advocating for trees. And my objective today is to equip you and assist you in making you a stronger advocate for trees by sharing with you some tools and strategies that address this wicked problem that we have that I think we can fix. So on the image here, you're looking at the surface of our Earth. These are images from NASA. On the left-hand side, you can see the gases that are at the, floating above our planet. And then I found this beautiful poster of the Earth Day of 50 years. We just passed Earth Day, and they've photoshopped this heart shape into this delta from a satellite image. More on satellite images later. So climate change is caused by global warming. And you'll bear with me, I'm just going to go through some of the doom and gloom stuff. So the global warming is caused by too many greenhouse gases in our atmosphere. And these gases trap this heat and warm our planet. So CO2, carbon dioxide, is responsible for about 65 to 67% of the greenhouse gases. And the number one sector responsible for greenhouse gases emissions in the US is transportation. So cars account for about 28% of this. And according to the United States Environmental Protection Agency, electricity production comes a close second at 27%. So transportation and electricity harm our planet because it takes power to generate energy, and we burn fossil fuels. Now, I know this is kind of like a primer for everybody, but I guess I just want to make sure we're all on board. So burning these fossil fuels release carbon dioxide, and that's what traps the heat in our atmosphere. So the bottom line, too much transportation and electricity means too many gases in our atmosphere that warm our planet. So who's emitting the most greenhouse gases? Well, consider this. While China is responsible for the highest number of emissions, we Americans have the highest carbon footprint per capita. This is probably not new news to anybody. But 100 companies, most of them oil and coal producers, are responsible for 75% of the world's greenhouse gas emissions. And the main emissions can be traced to cars, electricity, oil producers. And yipes, US citizens. So unfortunately, there's been a 1.62 degree Fahrenheit global temperature rise since the 19th century, which doesn't seem like much, but it's caused warmer oceans, which are causing glaciers to melt, sea levels to rise, extreme weather events such as hurricanes, floods, blizzards, even wildfires, and they're all getting more frequent and more severe. And if we continue, the projections are fairly dire. But I think we have the ability to turn it around. I'm a very positive and think that we can do this thing. So the NASA website has a beautiful system of recording global climate change through vital signs of the planet using satellites. I highly recommend that you check this out. It shows a picture of the Earth, sort of the visible Earth, and it shows all the different satellites flying around and that are measuring these different metrics. So let's dive into one of these amongst the ozone, soil moisture, sea level, carbon monoxide. It's just really cool to see this. So let's look at CO2. So this sort of picture of the Earth shows CO2 average distribution over the last month. So red and yellow areas indicate higher concentrations, while blue and white indicate lower. Unfortunately, we don't really see much of blue and white at all. And in fact, if you look at the chart on the top left-hand side, there's this level that CO2 stayed for millennia. And you can see that dashed line showing that it hadn't ever gone above that line until the 1950s. It began to crawl above that line. And now we're at the current level where we're almost double the height of that line. So yes, it's impacting. And here we see on the left-hand side, 1984, the both extent and thickness of the Arctic sea ice. And then you see it then in 2016 and how rapidly it's declined over the last several decades. Goodness, I was in college in '84. And so it's like, what? That was yesterday. So what can we do? Well, there's some obvious things like ride a bike to work, which is what I do, or car share, or use hybrid or electric cars, fly less. Other things like lower your cooling and heating bills by using energy wisely. Lots of things. Use reusable energy. Eat more meat-free meals, believe it or not, will help. And don't waste food. And better yet, grow your own food. Consume less in general. So those are just some general examples. Well, why trees? So the following information will hopefully help you advocate for the urban forest and the services it can provide. Franklin D. Roosevelt said, "Forests are the lungs of our land, purifying the air and giving fresh strength to our people." Boy, was he ever right. So let's put these trees to work. So what can we do? For starters, well, we don't want to use tropical hardwoods in our projects. We want to actually plant trees in our rainforests and protect what remains of them, because they are one of the most cost-efficient way to prevent the continuation of global warming. So trees absorb carbon dioxide, as we have already mentioned, and in fact, we could remove roughly 2/3 of the human-made carbon by just letting all our forests regrow. There's probably not a good chance of that, but we can do a little bit in our urban environment. This is an image of an oak I walk by every day on my way to work, and it's on the NC State campus. And just behind me, up to the left of the image, is D.H. Hill Library. This tree takes up almost as much space as the building adjacent to it, Scott Hall. I see hawks in it. I see all kinds of wildlife in this tree. For me, it represents the hopeful aspects of what urban trees can do. So here's some further strategies for why we should plant trees, which you can use to advocate. So just let's go over these 9, and I'm just going to keep sort of diving down into some of these strategies throughout the talk. So some 9 ways in which urban trees and forests can contribute to making cities socioeconomically and environmentally more sustainable. Well, they do contribute to food and nutrition security, and they increase urban biodiversity, like I just mentioned. And a mature tree can absorb up to 150 kilograms of carbon dioxide per year. So that helps to mitigate that climate change. They can cool the air as much as 10 degrees Fahrenheit under a tree. They filter for urban pollutants, absorb pollutant gases, filter fine particulates, and they can improve mental and physical well-being. They regulate water flow. For instance, a tree can intercept up to 15,000 liters of water per year. They reduce carbon emissions and also reduce winter heating bills by 20 to 50% if placed in the right place. They can also increase property values. So according to the Food and Agriculture Organization of the United Nations, for the first time in history, more than 50% of the world's populations now live in cities and towns. And it's expected to rise to 66% by 2050. So this human pressure has damaging effects on forests and landscapes, as well as the green areas around our cities, which are so vital today. Urban trees can help to mitigate some of these negative impacts and make cities more resilient to these changes and these population growths. A city with well-planned and well-managed green infrastructure becomes more resilient, sustainable, and equitable in terms of many factors. Throughout their lifetime, trees can thus provide a benefit package worth 2 to 3 times more than the investment made in planting and caring for them. A little bit more about that when I talk about some research my students and I are doing. So how do we design for healthy urban forests and in turn support a healthy community? Well, it's not it's pretty complex because we have to consider placemaking when we're in the urban environment and we incorporate trees. So streets and other urban spaces provide overall connectivity and accommodate movement, right? We have to move through our cities, but we're moving pedestrians and cyclists and cars and buses and trucks. So it's pretty complex, you know, our city streets. So these public open spaces can provide areas for people to recreate and contribute to the community's physical and mental health. I can tell you, especially these days of our shut-in, our local parks have been highly used. And here in a park near where I live, I see, you know, kids, you know, teenagers in hammocks, young families picnicking or walking in the park. There's a huge wingnut tree, massive canopy, and I see the children just running with joy and jumping up into and climbing that tree. So I can just, you know, it's just a wonderful sense of well-being. And in this image of Prospect Park, which was designed by Frederick Law Olmsted, you know, he designed these parks in New York City knowing that they would provide this and specifically mental health and health in general for the community. Other considerations is that the challenge is that streets and these urban open spaces have very limited cross sections, and lots of uses must be accommodated and encouraged within that space. And there's a variety of spaces. This is Fayetteville Street in Raleigh. These little placemaking spaces, these little tiny pocket parks. Raleigh has a couple of really nice ones too, but these are historic examples of famous ones, Paley Park in New York and Green Acres Park. We need these respites. We need these green spaces throughout our cities to give people this place to exercise and gather and really create community. So some components that you have to consider in the urban environment is building facades, lighting fixtures, cafe seating areas, traffic controls, utilities, street furniture, sidewalks, stormwater infrastructure. All these, you know, things have to all come together and incorporate the trees, their canopies, and their root systems. Well, we have some really cool examples historically. The top image here is the Champs-Élysées in France. It's basically made up of this grid of trees, some of which are kept pruned. And that really is the character of that street. Can anybody guess what the images are from below? This is an adaptive reuse of an industrial element. I'll give you a hint. It's in New York City. Another hint. It's in the meatpacking district. Yes, the High Line. Thank you. Right. So look at how trees are being used on the High Line. Now, the High Line is sort of unique because it could hold the weight of those trains coming in on that second level. And so it was already designed to hold the weight in this sort of green roof type planting. But look at the Cotinus, the smoke tree on the left-hand side, and what an impact that has on that linear park. And then the beautiful use of these birches on the right-hand side. Okay, so now we've talked about sort of some reasons why we want to do this. Now let's talk about the how we do this strategically and deliberately. And for me, it's the design process. Those of you who aren't designers, you can probably relate to this more. And basically, it's the process of critical thinking. So think about the expense of a square foot of land in a city, and think about how valuable that land would be when we put trees in the urban environment. This is why we have to use our critical thinking to optimize those spaces. So this is a chart I came up with to sort of show my students how the process of critical thinking, raising questions, formulating problems, gathering and assessing relevant information, goes hand in hand with the design process. So at the beginning of design, we develop our base maps, we do inventory of the physical, cultural, and experiential discovery of our sites, we do analyses of these inventories, and then we look at critical thinking, hallmarks, which is synthesizing and generating ideas and considering alternatives. Then we can parallel that with developing programs. What are our goals? And developing conceptual designs. How are we going to express those goals in the landscape? And then finally, in critical thinking, we reach conclusions and we communicate effectively and reflect on what we've done. Well, that's that schematic design and design development and development of construction documents, and then administrating the construction and then evaluating what we did. So if we look at that generally for design, we can look at all the aspects. But with another one of my students, we came up with strategies, almost like a checklist that you should address as you're designing for planting design. And I'm getting ready to teach that in 2 weeks, which I'm converting to online. So it's been quite an interesting experience here at this university, finishing this semester. But anyway, so this student and I came up with just some things that might happen during the research and analysis phase, like understanding the micro and macro climates, the hydrology, the topography, soil inventory, locating existing vegetation that could be protected, sunshade, all these things, historic or current species. What are regional biomes that were here way before? Define baselines and metrics of the site. Of course, engaging with stakeholders and understanding regulatory requirements. All these things could happen at the beginning of the design process. Then as you develop your concepts, you start thinking about space defining, transitions, ecosystem services like stormwater or climate mitigation or air purification. And then you might, at this point, do some precedent studies where, depending on what your goals are or what you've established for your design program, you might want to look at other places where they incorporated edibles or stream restoration or wildlife attraction or whatever goals you define. Then once you get to the design development phase, developing that planting plan and understanding your species that you're choosing and where you're going to get these plants and coordinating that with local nurseries. And then developing good plant details that support good growth, and then understanding how are these things are going to be maintained. Finally, the next implementation, so preparing that soil or substrate so that you have the best success for these roots to grow, and then planting them properly, and then managing them properly by monitoring their health and doing general maintenance. Now, a thing we typically don't do is evaluation. So how are our plants doing? And what are the metrics that we might use? We might think about water infiltration or water holding capacity of the soils or pollinator counts or even carbon sequestration, vegetation performance over time. And keeping records and reporting on these things can help us making future plant choices. So within that context, we think about, as we make choices, a strategy that mimicking natural systems is useful. So a plant's ability to thrive in its community is based on its ability to find required light, moisture, air, and nutrients. Each plant occupies an ecological niche and interacts with each other. The plants distribute themselves along the ground horizontally at different levels and vertically to accommodate their canopies and their cultural needs. We see this in nature. So our goal is to have complete cover, which signifies that that is a well-developed plant community. Now, we can't do this in our urban environments, but we can learn lessons from what's going on in our natural systems. And one of the things we see is a structural diversity and a seasonal diversity of plants. I asked my students to really go through and understand plant characteristics so that you can begin to define, and I just give them these checklists that I think might be useful. So first, you must find what plant best fits the site and use that you're trying to establish. And this is actually a fun challenge, and it's a challenge worth solving. So here's some of the lists that I give my students. So determine what the use of the plant is going to be relative to that whole design process. Then what aesthetic properties are you going to, look for in a plant? Its habit, its foliage, its form, what are some of the aesthetic aspects of the plant? And then special considerations. We don't want to put any plants that are poisonous or injurious or weak-wooded or invasive in our landscapes. And then we've got to establish what kind of maintenance is going to be available or necessary for the plants that we choose. And then, of course, we have to address cultural requirements like light, wind, drainage, how much growth zone, where it sits in the successional process. And all these things help us to develop our plant selection. So I love the saying, it's better to plant a 50-cent plant in a $5 hole than a $5 plant in a 50-cent hole. So all this stuff matters in making decisions as to, how you're going to prepare that soil and choose the right plant for the types of situations. And we're going to talk more about that. But in a nutshell, narrow down your functional requirements, your ecological, contextual requirements, your horticultural, cultural requirements, your maintenance requirements, and then generate a list of multiple plants that would do well on your particular project, and list all those characteristics. And that will help you sort of solve choose those possible plants. So as in nature, and we just mentioned, complexity is key. So what are some good examples of complexity and diversity? These are just some images that I've put together just to show that. Here we see a bald cypress growing in a streetscape, probably in a tree pit that's maybe 6 to 8 feet long, maybe 3 feet wide, and maybe hopefully 4 feet deep. Why do we choose a bald cypress for this stressful urban environment? Well, I could ask you, but we're not in a forum where I can really do that if we were in person. But probably some of you are guessing that bald cypress are used to low oxygen areas in the wet, loadic sites in nature. And so they tend to do well in these compacted soils with low oxygen levels. So these bald cypresses are well adapted to the stresses of the urban environment. Here's another workhorse. I know it's overused, but the willow oak. It also functions well. Here we see it in a beautiful, large, big continuous bed, but it's also done in little tiny parking lot and smaller tree pits. The Deodora cedar can tolerate compacted and poor soils, and here it is shown used as a design element, as a gateway. This is also in Washington, D.C., near the mall. Speaking of the mall, the American elm, with this height coupled with that vase shape, provides this amazingly graceful tree. And we saw it planted commonly along city streets and boulevards prior to the Dutch elm disease. They were valued because of their mature, beautiful canopies, and they provide benefits of cleaner air and cooler temperatures, of course. So the Dutch elm disease pretty much decimated these trees, but a few survive, and some of these cultivars that have since been cultivated are being planted back. And here's a relatively young one in Washington, D.C. Another one is tolerant of air pollution. Hope you can guess what this tree is. It's a planting of some young ginkgo trees. So ginkgos, and hopefully these are not female, because as you probably know, the female fruit is rather noxious with its smell. So the ginkgo is almost entirely free from insect diseases and is very good in the urban environment. Not to mention this lovely form that it has, and the fact that it has beautiful yellow leaves that somehow magically decide to all fall off at one time and create this amazing yellow blanket underneath. So very cool urban tree. Yellowwood copes with air pollution, has graceful branches, these stunning panicles of white pea-like flowers beginning right now. In fact, I just saw one yesterday in full bloom. They're fragrant, and even this coarse, big compound leaf that it has is interesting, as well as its bark. We also choose trees for their structural or spatial relationships. So this is something you want to sort of be deliberate about. So back to the American elm. Notice this pathway and the fact that you walk under this inviting limb that goes across this beautiful entrance, marking, yes, the signs help you find your way, but for me, that arching branch is almost like an invitation. We see that here in San Francisco, in Chinatown. They said, oh, you've got to go see the Chinatown gate. And yes, we found it. There it is on the right. Beautiful, interesting, all that stuff. But notice at the other end of the street was this other beautiful gateway, which was created by a tree. For me, that is just as impactful and beautiful and a transition into that space. So trees can also create almost like a room with a ceiling and columns, almost like a building, right? And shown in this cafe at a square in Maastricht with tilia planted to create this, remarkable space. Evergreens. These evergreens, and I'm sorry, I can't remember what they are, but they're in Washington, D.C., and they define this wall that encloses this beautiful fountain space. Trees aligning water's edges. This is in Providence, Rhode Island. Again, it's mimicking what nature might do along a stream edge, so an appropriate use. So ecosystem services. Here is a little tree planted between the parking spaces to, it's a sort of an innovative way. It's in the parking space. I believe it's a sycamore. And I don't know what type of root zone is underneath there, but we're going to talk more about root zones as the lecture goes on. Little tiny corridors. This is in Raleigh, in the downtown. Choosing the right plant can make these little spaces really magical. Speaking of magical, our beautiful willow oaks on Hillsborough Street that frame the street as you look down onto the Capitol. I think this is one of the most iconic and beautiful images of the city of Raleigh. And then, of course, we've got Fayetteville Street. I'm going to be talking more about that with the research with my student. And the methods that these trees are planted in. Look at all the uses they're accommodating across this, this street renovation. Just a few more, the difference of choosing a tree that would go in a tree pit that in this case looks like it's like 4 by 4, maybe hopefully by 4, versus this more continuous soil area where they're adapting the sidewalk by removing the pavers to give that tree the space that it needs for its roots. It's beautiful, it functions, and we still can accommodate that movement of pedestrians. what? What was here first? The white oak or the parking lot? There's two of these beautiful white oaks in these same conditions near where I live. This is behind the Red Dragon Chinese restaurant. And you just wonder how that tree has survived all these years with basically completely surrounded by dumpsters and cars and pavement. But anyway, so aesthetic, those tree roots, you know, look at this beech tree with the roots here are just as impactful and significant. Yes, we need a very large growing area in order to do this, but you know, those are the places we hunt for, that we try to find these large areas where we can grow these roots. Put a tree instead of a building. And then the golden rain tree, we got the beautiful flowers, yellow flowers in the summer, but look at the little lanterns with their orange fall color against this brick building. Again, this was in Washington, D.C., but I was stopped in my tracks when I saw this. Back to San Francisco, the Western red cedar, sort of mimicking the shape of this building. So we look at form, you know, and how that informs the landscape. One more close by. This is a brutalist building on the right-hand side, and some of you may have gone to that other school. Carolina. It's a lab. It basically has no windows and it's all concrete, but planted right in front of it is this magnificent catalpa tree. And we know why all these things could be valuable because of their flowering and their cool pods and the fact that they can do really well in urban environments. The locust tree, imagine this space, these famous steps at Montmartre in Paris. Imagine this space without these trees. It would be completely different. But notice what the trees are growing in. I'm assuming there's a lot of root growth going on underneath all that, the paving. And I do know that people don't walk on that side. They only use the steps. So back to my beloved NC State campus, and we're going to talk a lot more about how these institutional landscapes can provide areas for us to really grow our massive trees that are so valuable. Our trees have regenerative ecological potential. We have to identify that and make sure that we design for these things. In this example, we're showing trees growing with within water treatment areas. So the little rain gardens collecting the dirty water from these parking lots. I worked on a project in Chapel Hill at Meadowmont, one of the highest commercial real estate in Chapel Hill. And this is back in 1993 or 4, before all these, you know, stormwater focus was even happening. And we were just trying to make it a great people space. And we mimic nature to clean the water and create a really beautiful space. And now look at the size of that bald cypress. I think I took this maybe 5 or 8 years ago. Even work with, this is Dr. Hal House, who treats black water with vegetation. I mean, we can even think about that level of treatment. But when we think of trees, we also want to think of the temporal aspects that they bring to our landscapes. I have my students do a study of trees over time and the amount of growth they will put on at installation, at 10 years, and at 20 years. We're going to talk about the impact that, you know, the trees at 20 years are making much more of an impact than the ones when they're first planted. Also, I asked the students to do a seasonal study. So here they are through the seasons and how their trees might change. This was a clever student who used Photoshop to address that. But here's Cynanthus retusus. the Chinese fringe tree in its full bloom. It blooms early, it leaves out early, it has this magnificent bloom, and holds its leaves late into the season. Here it is where I used it at an entrance to a subdivision, making a stunning example of seasonality. Here's some more golden rain trees right here at the Harris Teeter in Cameron Village, near the university, really making sort of this moment with the seasonality of the trees. Productive trees. The no-brainer one is the fig tree. So here we have trees that provide food. And I can't tell you how many people come to get the figs out of this planting behind Kilgore Hall where I work. It's not only students and faculty, but people from the community on weekends come with their ladders, and I may be giving this away and giving you a place to go gather figs. But in any event, just when you walk through this courtyard and you smell that fig smell, and you know, I'm able to walk outside my office and walk out there in the summer and pick my fig, and if I forgot my lunch, there I go. That's my lunch. Here's with my friend David and Terry Swanson walking in a project in, I can't remember if it was Harbor or Chapel Hill, but look at the size of that fig tree and what an impact that has for that community. Let's don't forget our green roofs. Now, of course, we have to design for structure in green roofs, but here's the ASLA headquarters in DC, and you can see that they have a little tree on the left-hand side, but for the most part, they restricted their plantings to smaller, extensive, you know, plant material rather than the intensive, heavy material. All right, so now we've gotten to just giving you some general perceptions and ideas for thinking about trees. Now let's talk about a little bit about evaluation. I'm going to share two projects very quickly that I did with my graduate students. And we're going to call these like the gold standard strategies that we discovered. So the first one I want to talk about is the sustainable residential design. We evaluated aesthetics, environmental, and area use as an assessment. And our questions were, what levels of sustainability are seen in different approaches to residential design, and which of these aesthetically are preferred by people or residents? And how do designers allocate and locate outdoor areas in the residential design to make them more sustainable? So we studied 6 sites, and we called them, we had 3 levels, so high sustainability, medium, and low, or permaculture, sustainable, and conventional. And we chose 2 sites for each one of those categories. And then we looked at them through the lens of the Sustainable Sites Initiative rating system. And we rated them for credits in the topics of water, planting, and gathering and circulation. So we gave them sort of ratings for each one of these areas. And we looked at 16 different landscape elements. We evaluated them and made comparisons, which I'm not going to share because we don't have enough time, but I do want to share the pilot project. So after my students do their research, I have them apply it to a site. So this is a residential site that my student applied what she discovered. And what she discovered were these categories that were necessary for landscapes, for residential landscapes. One of the most significant ones was the south side and west side trees and the impact those had in the design. I can tell you because my west side of my house had a tree from the neighbor's yard that gave it beautiful shade from that harsh afternoon southwest sun. Well, they took the tree down and put in roses, which made my house extremely hot. I immediately planted a shade tree, and it's 20 years old now. And now we're going to talk about that tree a little bit more, but you can see at the front right corner of the design where the south side tree is planted to provide that cool, and it's a deciduous tree. It provides that coolness to the house to help reduce the amount of energy it takes to cool the house. And here's just a section showing how she incorporated edibles and shrubs and that shade tree to the design project. Then she compared it to all the evaluations of the different landscapes that she evaluated. So you're just getting a little tiny picture of her research. And you can see the ones in red were the most sustainable sites that we looked at. And then the medium sustainability are in the green in the middle. And then the conventional residences that had really no real attention at all to sustainability are in blue. And you can see the pilot study began way down in the existing with this purple line. Let's see if I can use my pointer. There we go. Way down here. And after my student implemented the design strategies that she established in water, planting, gathering, and circulation, and then she ran it through the Sustainable Sites Initiative rating system, all those categories went up. So the reason to show you this is not only just to inspire you to do these strategies, but if we did just that one southwest tree, shade tree per site, even one at a time, maybe you didn't do edibles, maybe you didn't do all the shrubs and things, but maybe if you just did that one tree, in combination over time, this could accumulate and make a huge dramatic improvement in our use of fossil fuels. So this attention to detail and this robust design process proves valuable to us. Okay, so I'm going to share one more project that's a little more involved because this is about urban trees in Raleigh. So my student and I in 2011 looked at some plantings, street tree plantings in Raleigh. So we know that neighborhood trees and street trees provide shade for the streets and for the parking areas, and they add value to our properties. They cool the air and they absorb carbon dioxide. So these, again, we know it lowers temperatures and that reduces the heat island effect, that holding of heat. So what did we do? Well, there was a lot of information, but there wasn't much comparison of these different strategies of how trees are planted in the streetscape. So we looked at 6 streets in Raleigh and 7 planting methods. Ooh, I'm going to have to fly through because we're almost out of time. So we need as much, we would like to have 2,200 square feet, but 500 to 1,500 is bare minimum. So here are the 6 sites in Raleigh, and each site we went through, and I'm just going to speed through, and looked at all the aspects of both sides of the site and characterized them. And we took each one, McDowell Street, this is what it looks like now, Hillsborough Street by the university, and Hillsborough Street by the Capitol, you saw that image earlier. Fayetteville Street, again, they used structural soils. Wilmington Street, they used the tree pit. And we compared all of them, and I'm sorry I'm having to go fast because I want to end on time. And the different types of planting types, we used iTree to calculate the value. We found that the beautiful oaks on NC State's side of Hillsborough Street, which had continuous soil areas for their roots, had the highest value, and the lowest value were the trees that were planted in the tree pit in downtown Raleigh on Wilmington Street. Wilmington Street. We looked at behavior, and I'm not going to go into that because we don't have time. But we looked at the cost of planting those trees in the different strategies, and we were trying to figure out, okay, well, what would work best to make our trees high value. So we can expect our trees to live longer if they're in continuous soil with lots of root zone versus standard soil, which is that tree pit, which only lives 7 years, structural soils, which claim to live 25, and Silva cell structures for 20 years. And then we looked at the cost of those, and we combined those two and assigned, okay, if you planted the first year, it has sort of a low value, then a medium impact, and then a high impact as they get large and create shade trees. So this is a little diagram showing that. And again, I apologize, but I just realized that we only have 4 minutes left. So we looked at...
Julietta, you were good until 11:15, so you have some time.
Okay, good. Well, I'll slow down a little bit. Thank you, Leslie. So we looked at all of these and we said, okay, if you have to replace that tree every 7 years, over 50 years, every time you spend that money, over time, you're spending $9,100. The same with the Silva cells, they last longer, so you're not replacing them, as often. And then the structural soils and so forth, and then the continuous soil where you have the massive root zone areas. So we really want that continuous soil area rather than the little pit that we do the trees, because obviously we just barely get to the high impact in those, and then we got to replace them. So we looked at cost over year and found, again, those where we have soil, but that's not really feasible in our urban environments. But look how expensive structural soils and Silva cells are over time. But we put it on a chart and we discovered, we knew the continuous soil, that's where we kind of want to be, but we don't always have that large amount of space. So these two at the top are the ones we wanted to focus on for strategies. So just like my other student, I asked her to apply this to the poorest performing street, which was Wilmington Street. And so she chose to use the Silva cell system. And she chose the Chinese pistache, which is a very good urban tree. And you can see above the existing planting, and then below how she planted with good spacing, and she, with the use of the Silva cells, providing the root zone underneath that pavement. She even included that example from the tree being planted in the street. So she's proposing 4 of those. So she really made a difference in the trees from the existing cross-section that you see up at the right-hand corner to her proposed beautiful cross-section, with some trees even in the parking areas and good healthy trees in the streetscape. Here's her little sketch of how that would work. And then she ran the numbers, and if we kept it the way it is, you see at the top how many times it would have to be replaced. And if we use that Silva cell, we could have that long-term, high-quality tree, and over time save money. So this is a call to action for all of you to act locally and impact globally. I guess I'm showing my age here. I remember that being a big thing when I was in school. I hope that you've discovered some perspectives and strategies. Whoops, my slide advanced by itself. To improve the success of the trees in the urban environment. And you have sort of a lens now to look at, or maybe a tuning fork that you can modify or adapt to your specific sites using the design process to identify those needs in the urban environment. Now you kind of know how important it is to choose the right plant for the right place for your specific site. And we can re-envision our urban forest and adapt to this new sort of ecological and economic and culturally sensitive way. I want to just finish with, remember the white oak I mentioned that I planted that is finally giving me some shade? from that western sun. I used iTree, and I just want to advocate for this as a metric that you can use for that tree. And I discovered that my little 5-inch caliber white oak has provided overall benefits. And you can see the tabs above, and you can see stormwater by itself. So this is a really cool tool to share with your clients, members of the, whether you have a committee that you're working for or whatever. Help to avoid 313 gallons of stormwater runoff. I mean, I just get excited thinking about just that one little tree that I planted from an acorn. They were the Millennia acorns, and my son and my nieces and nephews and I planted them in little pots, and that's what that tree is from. And I'm sorry I don't have a picture of it, but it's reduced cooling, it's removed, CO2 and sequestered carbon. So that concludes my presentation, and I hope I have equipped you with some tools, some inspiration, and evidence that gives you confidence to have the capability to say that we can all be deliberate about designing with trees in the urban environment and save us all, the whole planet. And thank you.
All right, excellent. Thank you so much, Julietta. If you would like to unshare your screen, I can get our the question ones coming up. But so now's the question answer period. She went over a lot of information and a lot of techniques and design concepts. So it's a chance for anybody to ask a question and get her response back.
I did see someone ask about Greenacre Park. That's in New York City. It's actually just down the street from Paley Park.
Okay, excellent. Thank you. Okay, so if you want to type in your question to the chat box, we'll address them each. We have a question that came in for you, Dr. Shirk. Have you considered the Stockholm solution approach to urban trees? This person's heard interesting things about it.
The Stockholm solution?
Yes.
No, I would like to learn about that. I have to say that trees are not the focus of my research, really. But of course, but thank you for sharing that. I'll have to look into that. Thank you.
We had another question come in explaining, if you could explain just a little bit about what a Silva cell is. That would be great.
Yeah, it's a really interesting system that it almost looks like an eggshell of, and I showed some details in the PowerPoint of plastic structure that is open, and these plastic columns hold a sort of a bed for the paving to go on, so that the people that are walking above it aren't compacting the soil, and you fill those voids, sort of the eggshell voids, with good organic soil to grow in. But I recommend that you Google that, and they have lots of information. But what's really nice about that system, yes, it's expensive, but it has roots growing in native soils. And the structural soils that we saw in downtown Raleigh don't have that level of organic material. So it'd be really interesting to see how these trees evolve. But one thing I haven't mentioned is the fact that in both systems, the trees that are adjacent to each other, their roots intermingle. And that tends to make all the trees very thrive. They kind of like to have their friends and hold hands underground. So I see a question about what I'm teaching this summer. So I'm just finishing my exams for grading and drainage and hand graphics. And I have a floral design class right now. We're just taking exams. And in mid-May, which is 2 weeks away, I start teaching a plant identification and a planting design class for the landscape architecture program at the College of Design. And it's going online for the first time, so I'm a busy girl. Let's see. Oh, Yellowwoods in the urban environment. Did they have any major maintenance concerns or pest disease issues? What is your experience? The most successful Yellowwoods I've seen in the urban landscape that are 30 feet tall have been in areas where there's plenty of root zone, and we can kind of know this